And we're back for the final part, part C, for our question number 47. Just to reiterate, a Major League Baseball diamond is actually a square 90 feet on a side. The pitching rubber is located 60.5 feet from home plate on a line joining home plate and second base. So part C asks if a pitcher faces home plate. So let's bring this side by side next to our picture here, just so we get a good view of what's happening. So the pitcher is going to be facing towards home, so he's here, look this way. What angle does he need to turn to face first base? So he's going to need to turn this angle, and we don't know what this angle is yet. So let me draw which way he'll be facing. Here we go, and hopefully I can draw a good solid arrow here. He's going to go this way, he's looking that way, right? So what we have to do now, and I've stated this before, I said that you could use the law of sines interchangeably. You can go from sine A to the other A, and sine A over A to the sine C over C without going to sine B over B. This I found is not true. You actually have to go through the process. So you have to do sine A over A to get sine B over B, and then that result will give you to sine C over C. So let's follow that method, and just so you can see what I'm talking about. So the sine A over A, sine B over B, and sine C over C. So you have to actually follow these steps to get the answer. So let's find out what our angle is using the law of sines. And right now we have sine A, and let's write out what we have. Keep it on track here. So we have angle A equaling 44.9 degrees. Stretch this out a little bit. Here we go. We have side A, which is equal to 63.61, and we need to find B here, and the side for this is going to be 60.5. These are feet. Keep that in mind. Now that we have our values, let's plug them into our equation. Alright. So we'll come back to that, what we just saw a second ago on the pad. So angle A. So we're going to have sine A, which our angle A is equal to 44.9 degrees. We'll leave the degree off here. Over A, which is 63.61. And just so we keep track, this is the law of sines that we are using. And it's going to equal to sine B, which we don't know yet. So sine B over B, which is 60.5. So let's calculate that. So 44.9. We need the sine of that, which leaves us with 0.705 in this little number. We're going to divide that by 63.61, which leaves us with 0.011, and again, a big number. So let's copy this, place it right here, and it's going to equal to the sine of B over the 60.5, and we're going to multiply both sides by 6.5 to get rid of it from the right side. So let's multiply this by 60.5, and it's going to equal this big number again, and we're just going to place it here just so we stay organized. And of course the 60.5 has been cancelled out on the right side. So what we have left is sine of B. Well, we need to get B on its own, so we have to get rid of sine. So we're going to use the arc sine, or the inverse of sine, to calculate what B is. So let's do that. So let's get rid of sine on this side by dividing it by sine, and then over here we're going to use the inverse of sine. and it's going to leave us with 42.17 or 42.2 degrees. So we'll say 42.2 degrees is B, or if you this is a better look for you, 42.2 degrees, and that'll be our angle here. So this angle, excuse me. So this angle here is 42.2 degrees. So throw that in there. 42.2 degrees. So we're almost finished. This last part is pretty simplistic. So we know that 180 degrees makes up a triangle. So there is 180 degrees in a triangle. And so far we have 44.9 degrees and 42.2 degrees. So what we can do here is add 44.9, or we'll write it this way. So there's 180 degrees minus the 44.9 degrees plus the 42.2 degrees. And we'll put these in parentheses because we must do this first. So what's left is 44.9 degrees plus the 42.2 degrees, which comes out to 87.1. Just because I like to go through steps, I'll write it out. 87.1. And what's left of this, so 180 minus the 87.1 will give us our last degree, which will be a 92.9. And I'll write that down. 92.9 degrees. And we'll place it right here, 92.9 degrees. And so now we know that the pitcher who's facing home plate needs to rotate 92.9 degrees to see first base. Alright, well, I hope this has been educational and will help you along through your class. If you need more help, just give me a ring and I will try my best to help you with any other questions that you have. Alright, well, have a good one.